Now the key with the dilutions, okay, the key with the dilutions is to remember that M1 V1 is equal to M2 V2. Now, why is that a correct statement? We talked about it yesterday. Why is this a correct statement that the two of those are equal? Because the moles are the same. All I'm doing in a dilution is adding more of the solvent to change the molarity. So the number of moles are the same. If you remember, I had the little cup. I added 3 drops of food coloring, then I put it into the big flask and added more water. I didn't add any more drops. Those drops represented the moles. So M1 V1 is equal to M2 V2. So what is the M1 and the V1? M1 is the molarity. V1 is the volume. M2 is the second molarity. V2 is the second volume. Now, does it matter? Does it matter what I have my volume in? Okay, you should have got that from the video, right? Volumes don't matter just so they are consistent. I could have liters. I could have milliliters. I could use gallons. I could use buckets, just so my measurements are consistent. Now, if I look at this one, do I have consistent measurements on my volume? No, so I'm going to have to change something. I'm going to have to change something with this one. Now, it says if you dilute 175 milliliters of a 1.6 molar solution of lithium chloride to 1 liter, determine the new concentration of the solution. M1V1. My M1 is my initial molarity, and that is a 1.6 molar solution. I multiply that by my initial volume. I'm just going to leave these in milliliters. So I'm going to have 1.75 milliliters. I am trying to determine a new molarity. So M2 is unknown, but I do know that I have 1 liter. And I'm going to convert that 1 liter into milliliters. So basically what I'm doing, I'm dividing both sides by 1,000. My milliliters are going to cancel. So I'm going to have M2 will be equal to 1.6 times 175. And then I divide that by 1,000. And I get 2.8. And my label is going to be 2.8 is not right. 0.28 molar. Now that's a point right there to make, folks, is when I'm making this dilution, okay, it's why I jumped back there a little bit when I made that, as I said, okay, 2.8, and then I looked up at the top and said, well, I started with 1.6. Can those things be going up? Are my molarity, if I'm diluting something, will my molarity be going up? Yay, nay? What do you think? What do you think? Once again, here's the question. If I'm diluting something, should my molarity be increasing? Okay? My M2 should be going down. So if I am diluting something and I came up with an example or an answer like I just did there of 2.8, I should be sitting there saying, wait a second, something is wrong. Well, what's wrong? I can't read my calculator. That's what's wrong. So instead of the 2.8, should have been 0.28 molar. Go ahead and copy down the second example, and then we will work. I have 345 milliliters of a 1.5 molar sodium chloride solution. If I boil the water until the volume of the solution is 250 milliliters, what will the molarity of the solution be? Now, for this particular problem, is this actually a dilution? Am I diluting this? I'm not, am I? I'm not increasing my volume on this one. I am decreasing my volume. So what should happen to my molarity? It should go up, right? It should go up because I am going to end up having a lower volume with the same amount of moles. So, M1 is going to be 1.5 molar. V1 is going to be 345 mLs. I do not have M2 once again. I'm trying to calculate that. And my new volume is 250 mLs. I can look up here and I see that, ladies and gentlemen, remember, is only two significant figures because that 0 is a placeholder. But it shouldn't matter because I've got two sig figs right there also. You should have got that easy. So, as I'm looking at this, M1V1 equals M2V2. I need to solve for M2, so I'm going to divide both sides by 250. So M2 is going to be equal to 1.5 multiplied by 345. Divide that value by 250, and I should have a molarity that is greater than 1.5. Okay. And my molarity now is 2.1 molar when I sig fig it. I got 2.07. When I sig fig it, it should be 2.1. Therefore, I did increase my molarity by boiling off some of the water that was involved. Now, this last example is, you're going to see a few of these on WebAssign. It's a little bit more challenging. So copy this one down and we'll work it. But like I said, you're going to see these on WebAssign. So make sure you have some examples of these, and you already have one. This will be our second one. A 40 milliliter volume of 180 molar iron 3 nitrate solution is mixed with 21.5 milliliters of a 0.808 molar iron 3 nitrate solution. Calculate the molar concentration of the final solutions. Well, what I'm doing here, folks, is I have two different solutions with two different concentrations two different volumes. I need to find out what my final molarity will be. Okay? So it says calculate the molar concentration. What I need to do is to determine the number of moles that are in each solution. I know that molarity times my volume is going to give me my number of moles, correct? Now, since I am not just comparing these two things, what I'm going to do is I'm going to make sure that I have my volumes in liters. Because when we define molarity, it is moles per liter, correct? So I am going to make sure that I put my volumes into liters. So I'm just going to take the first one up here in blue. I have a 1.80 molar solution, and in that I have 0.040 liters, correct? Yep, I converted that correct. So when I determine my number of moles, I take 1.8 and I multiply by 0.040, and I come up with a value of 0.72 moles for that solution. My second solution, I have 0.808 molar, and I have 21.5 milliliters, which is 0.0215. So when I find my number of moles for that one, I came up with a value of, make sure my math, I'm doing it right, 0.017372 moles. Now, when I mix these two solutions together, I'm going to have the amount of moles that are there if I would add those two together. So when I add these two together, I get 737372. So when I add those together, that's not. All right. Time out. Let me go back. Because this number's wrong, isn't it? 0.072. Is that correct? Man, oh man, I'm having a lot of trouble reading this calculator this morning. Okay? So, when I added those together, I came up with 0.089372 moles. Does that sound a little bit better, Rachel? All right. So, I now have the number of moles that are in the mixture, correct? What is the volume of my mixture? Okay, what is the volume? Because in order now to get the molarity, I'm going to take my number of moles that I just calculated, and I'm going to divide that by the volume of the solution. Well, I started out with 40 milliliters of one. I added to it 21.5 milliliters. But since I had those into liters, I get 0.0615 liters, correct? So when I do my math, I take the 0.89372 and I divide by that the number of liters I have, which is the 0.0615. So my molarity is going to equal 1.4. Let me go back to my problem, see how many sig figs I got. 3333 on all of them, so 1.45 molar solution. So by mixing those two solutions, okay, by mixing those two solutions, the 1.8 and the 0.8, I come up with a value of 1.45 molar. Does that make sense? When I mix the two, they should be in between the molarities of my two values, shouldn't they? Yes, they should be. Okay? So, 1.45